Hi guys, in this video we are going to discuss chapter 3.1, the remainder theorem and the factor theorem. If p of x is a polynomial function in x, then the values of x for which this p of x is 0 are called the zeros of p. It means we are finding the x-intercepts of the function p of x. An example has been given here. Example, p of x is equal to x cube minus 12x square plus 20x. We want to check which one of the given values, x is equal to 1 or x is equal to 2. That's a 0 of p of x. So substitute x is 1 here and p of 1 and check the values. P of 1 cube minus 12 1 square plus 20 times 1, which is 1 minus 12 plus 20. This is 21 minus 12, not equal to 0, not equal to 0. So 1x is equal to 1 is not a 0 of p of x. Okay, and similarly check x equal to, there are many other techniques we can use to find the zeros here, but just a very simple one is the substitution. X is equal to 2. When you substitute x is equal to, what is p of 2? 2 cube minus 12 times 2 square plus 20 into 2, which is 8 minus 12 into 4, which is 48 plus 40. You see here, minus 48 plus 40 plus 8. This is 0, equal to 0. So x is equal to 2 is a 0 of the polynomial function p of x. Okay, what's next? Next, some graphs, graph of zeros of polynomial. So for this function, x square is x square minus 5x plus 6. X is equal to 2 and x is equal to 3 are zeros. You can find that when you factorize this one, it will be x minus 2 times x minus 3. This is x minus 2 times x minus 3. So x is equal to 2 or x equal to 3 will make this polynomial into 0. When you see the graph of this function, you see 2 and 3. This 2 and 3 are x-intercepts. X-intercepts. For function of degree 2, there will be one concave up or one concave down. If the degree is 3, there will be two concaves up or two concaves, one up and one down will be there, isn't it? So kind of graphs we can see. So from this graph I want to show you that x equal to 2 and 3 are the x-intercepts of the given function. Next is the remainder theorem. If a polynomial p of x is divided by x minus c, the remainder equals to p of c. It means there is a polynomial function p of x in any degree, and you are dividing the polynomial by a binomial x minus c. Then the remainder, if you want to find the remainder, directly put this value c in this place of x and check what is the answer is 0 or non-zero. If the 0 is the answer, then remainder is 0. It means it divides, right? And if it is non-zero, what is the value? You can find the exact value. That is the remainder when you substitute the c in this p. For example, the previous example we can take here, what we have taken, p of x is equal to x cube minus 12x square plus 20x divided by x minus 1. We will see x minus 1. So what is the remainder? Remainder, when you divide this polynomial by x minus 1, what is the remainder? See, we are going to use synthetic division here to find remainders, but directly you can check the remainder by putting c is equal to 1 in this polynomial. P of 1 is equal to 1 cube minus 12 times 1 square plus 20 into 1. This is 1 minus 12 plus 20, which is 8 here. Minus 12 plus 20 is 8. 8 plus 1 is 9. The p of 1 is 9. The remainder theorem says that if you substitute the c value from the binomial, if this is x plus 1, then the c value is minus 1. Okay, when you substitute this c value in this p instead of x, whatever the answer comes, it is the remainder. This is remainder theorem. Okay, next, factor theorem. A polynomial p of x has a factor. See, you are dividing this one by x minus c. It's a fact. This x minus c is a factor if and only if p of c is 0. It means when you find this, when you substitute the c in the p of x, when you substitute the c in the p of x and the answer is 0. In the previous case, when you substitute p of 1, the answer was 9. It's not equal to 0, isn't it? So if the answer is 0, then this factor x minus c is a factor of p of x. Then the c is, if and only if c is, they are equivalent results. Okay, c is 0 of p. So what they say, what is our p of x? P of x is x cube minus 12x square plus 20x, and we can check x minus 2. When you divide by x minus 2, what is c? C is 2. Can I substitute 2 here? X is 2. 2 cube minus 12, 2 square plus 22. We have already checked, the answer is 0 because it is 8 minus 12 into 4, 48 plus 40, and the answer is 0. The answer is 0. It means p of 2 is 0. It means x minus 2 is a factor for the polynomial. Also, x is equal to 2 is a 0, that we have already seen, isn't it? So this is the factor theorem and remainder theorem. Now we will use synthetic division to identify the remainder and factors. What is synthetic division? Let us see with this example. Write the coefficients of, this is the given polynomial p of x, and the dividing binomial is given. From this binomial, find c. What is your c? C is minus 3. This is x minus c, isn't it? It must have been, c must be minus 3, then x plus 3. Okay, we are going to divide this polynomial by this binomial. Synthetic division can be used here. How to use synthetic division? Write the coefficients of the polynomial starting from the highest degree of x towards the constant term, isn't it? Write all the coefficients. The highest degree is x cube. The coefficient of x cube is 2. The next degree must have been x square, but there is no x square here, so its coefficient is 0. And the next degree of x is x power 1, and the coefficient is minus 8. Finally, the constant term 7. So if any term is missing, even the constant term is missing, that place should be filled by 0. And now let's use the c value here. C is negative 3. Start with writing 0 here. Downwards, add them. 2 plus 0. 2 plus 0 is 2. Multiply with the minus 3 and write here. So this is minus 6. Minus 6. And again vertically add them. Downwards, add them. Multiply with this minus 3. Add, this is minus 6. Multiply with the minus 3. It is 18, positive 18. Add downwards. Minus 8 plus 18. Yes, 10. 10 into minus 3. Multiply this 10 with the minus 3. It is minus 30. Now add, at the end you will get remainder. This is the last term, so we will consider this is our remainder. Minus 30 plus 7 is minus 23 is the remainder. And what is your quotient? The quotient is this one, q. Quotient. you know, divisor is this x plus 3. Instead of x plus 3 we use only the c value, okay, to divide. And this, the polynomial which is being divided is called dividend, and this is a divisor, quotient, remainder. You must know these terminologies, okay. Now the original polynomial is of degree 3, so the quotient will be decreased, reduced polynomial when the remainder is 0. But okay, if the remainder is non-zero, this is just a quotient. What is it? 2 minus 6, 10. So 2 should be accompanied by the degree 2. 2x square minus 6x plus 10. You see, the degree of the original polynomial is 3. When you divide it by a binomial, you get the quotient as an equation, a polynomial in degree 2. This is q. But you see, for example, I will use a number theory concept to you. When you divide 7 by 2, what is happening? 3 times 2 are 6, and the remainder is 1, isn't it? So you can write 7 over 2 as 3 plus 1 over half. So 3 and half, 7 over 2. So this 3 is quotient, the 1 is a remainder, and the 2 is divider, isn't it? So any rational form expression can be written in this form: q plus r over d. Q is quotient, r is remainder, d is divider. So divider is x plus 3 in this case, remainder is minus 23, quotient is this one. When you use all the information in this rule, you get this. You see? This 2x cube minus 8x plus, actually you are dividing. This is the division, isn't it? This is the original polynomial divided by x plus, so 7 over 2. It means original polynomial divided by the binomial x plus 3 is equal to the quotient. You see, quotient is from here, q. What is it? 2x square minus 6x plus 10. And the remainder minus 23 divided by the divider. This is it. This is it. Okay, this procedure is called synthetic division. And now another example 3 says, use remainder theorem to evaluate a polynomial function. So you got a polynomial function p, and use remainder theorem to find p of c. C values are given here. Let us use, see, instead of substitution, the synthetic division will be easier to find p of c. Let us see what is the remainder. If the remainder is 0, then this value is a 0 of the polynomial, otherwise not. That's all. Okay, let's find p of c. There is no question about this factor or 0 of this polynomial. We just want to find p of c. Let's write the coefficients of the polynomial first. For case A, when c is minus 2, 2 for x cube, 3 for x square, and 2 for x, and the constant is negative 2. And divide, synthetic division, the c is minus 2. Just add a 0 here and then downwards addition, 2 plus 0, 2. Multiply with the minus 2, this is minus 4. Vertically add them, this is minus 1. Multiply with the minus 2, you get 2. Add, it will be 4. 4 into minus 2, minus 8. And the addition is minus 10. This is remainder, r is minus 10. So you get p of c, which is p of minus 2 is minus 10. Second case, B, c is half. Okay, now the same coefficients, 2, 3, 2, minus 2, but the division takes place with the half. C value has been given half. Okay, so here the binomials are, when c is negative 2, the corresponding binomial is x plus 2. When c is half, the corresponding binomial is x minus half. Okay, fine. or this binomial could have been 2x minus 1 as well. We will see. Now just add 0 here, and then vertically add 2 times half is 1, and vertically add it is 4 times half is 2, add them, then this is 4 into half will be 2, positive 2. When you add these two, you get 0, remainder is 0. So p of half is 0. So we found the answers of p of c. Further, you can conclude a lot from this one. When half is 0, we understand. So now I am erasing this board, and I am writing some more conclusion. Okay, you understood that p of minus 2 is minus 10 and p of half is 0. By comparing the concepts of remainder and factor theorem, we understand here that x is equal to half is a 0 of the original polynomial p of x. First information. Second, x minus half is equal to 0. X minus half. This binomial is a factor of p of x. You can write this x is equal to half in different way, because when x is equal to half, multiply 2 on both sides. 2x is equal to 1, which is 2x minus 1. Also 2x minus 1, instead of x minus half, you can write 2x minus 1 is a factor of p of x. So x is x minus half or 2x minus 1, isn't it? It's a factor, because in the 2x minus 1, put x is half, 2 times half 1 minus 1 0. So x is half, is written in different way. It's a factor of p of x. Third, the original polynomial can be expressed when the remainder is 0. When the remainder is 0, all these are equivalent results. You can write original polynomial p of x as the product of quotient. What was the quotient in dividing by half? One more time I want to recall it. 2, 3, 2 minus 2. When you divide it by half, it was 0 and 2, 1, 4, 2, 4, 2. So this was the quotient, which is 2x square plus 4x plus 4. So this is also a factor, 2x square plus 4x plus 4 times 2x minus 1. Or you can write x is x minus half times x minus half. So original polynomial can be expressed as the quotient times divider when remainder is 0. Okay. And the fourth point is this x value, x is half when y value 0, is an x-intercept of the function p of x. Finally, fifth point, when the remainder is 0, the quotient will give you reduced polynomial 2x square plus 4x. We'll write here. The fifth point in the case is point number 5. The quotient 2x square plus 4x plus 4 is called reduced polynomial. And including this p of half is 0, there are many points we can write. When the remainder is 0, these are equivalent statements. So you get a reduced polynomial from the quotient, and the multiplication of the divider with the quotient in the reduced polynomial will be giving you original polynomial and x-intercept factor, 0, all are true for this statement. P of C is 0. Whereas this first case, when P of C is equal to minus 2, you can express the polynomial P of X into quotient plus remainder over divisor form. And other parts are not true. Other parts, this C is minus 2 is not a 0. Other points that we have written for C equal to 2 are not true for the first case. That's it. The next question is apply factor theorem. Now this is a practice problem to you. You can try. Use synthetic division and check which of the answers are good. X is here. What is C? C is minus 5. For second binomial, C is equal to 2. So divide it by minus 5. So use synthetic division. X power 4, 1, x power 3, coefficient 1, x power 2, it is minus 21, x power 1, minus 1, constant 20. All the terms are available from power 4 to the constant. So divide it by minus 5. Use synthetic division. Use 0 here. 1 plus 0 is 1. Multiply with the minus 5. You get minus 5. Add with the 1. This is minus 4. Multiply with the minus 5. You get 20. Positive. And add it. You get minus 1. Multiply with the minus 5. You get 5. Vertically you add. You get 4. Minus. Multiply with the minus 5 will give you minus 20. And the answer is 0. When the remainder is 0, there are 6 different points, isn't it? Probable, the function value when C is minus 5 is 0. Second point, X is minus 5 is 0 of the polynomial. X plus 5 is a factor. This is third point, isn't it? Fourth point, the quotient times divider. P of X is equal to the degree of the original polynomial is 4. So reduced polynomial. What is reduced polynomial? Point number 5. Reduced polynomial. Reduced polynomial is starting from x power 3. X power 3 minus 4 x square minus x plus 4. This is the reduced polynomial. And the original function P of X can be expressed as x cube minus 4x square minus x plus 4 times x plus 5. Okay. And what else? What do we miss next? And x intercept. Point number 6, you can write x is equal to minus 5 is, or minus 5 comma 0 is an x intercept. Okay, that is it. So try these things for x is equal to 2. If you get 0 as a remainder, then these 6 points are equivalent. If it is non-zero, then you will write only P of 2 is not 0. Divide and check. Okay. Next, find a reduced polynomial. Find a reduced polynomial. So if you divide this polynomial by x minus 3, the answer remainder must be 0. Then the quotient is called reduced polynomial. Check the remainder is 0 or not, and this work is left to you because the idea has already been discussed. Next question, a different type of question. Determine the value of k so that the divisor is a factor of the dividend. Okay, again synthetic division we are going to use. This k is not given. K is any constant. What value of constant makes this divisible by the binomial? Let us again start the synthetic division. Write the coefficients: x cube 1, x square minus 1, minus 14 for x. Constant part is just k. We don't know the value of k. And now c. The c is 2. So divide. Use 0 here. 1 plus 0 1. multiply with 2, 1 into 2 is 2, addition will give you 1, 1 into 2 again 2, vertically add them, it is minus 12, multiply with 2, this is minus 24. So if you want to get a factor, remainder must be 0. If you want to say x minus 2 is a factor, if and only if p of 2 must be 0, the remainder must be 0. So what value of k makes the remainder 0? k must be positive 24, that's all. K must be positive 24. That will make, if this value is 24, then 24 minus 24 is 0, isn't it? For a remainder 0, then this x is 2 is a 0, or x minus 2 is a factor, or this is a reduced polynomial. There are 6 equivalent results you can write, okay? And these are your practice problems. What is the remainder when we divide this polynomial 6x cubed plus x square minus 2x plus 4 by x minus 2? Here c value is 2. Put this 2 exactly in place of x and check. That is one way. Otherwise, use synthetic division and check your answer out of this 4, isn't it? Find which one is your possible answer. The answer is given here. You can try. Second one. The next practice problem is divide this one x to the power 4 minus 3x plus 5. You see, while you write the coefficients of the x, be careful. X power 4 is of coefficient 1. There is no x power 3, 0. X power square part is 0, and then minus 3 plus 5. Okay, in that way you write the coefficient and divide 2x minus 1. How do you divide this one? You must remember 2x minus 1 is 0. Take it to 0, so 2x is equal to 1, x is equal to half, so you can pick c as half, and then use remainder, the synthetic division to find the remainder. Okay, check this one, the answer you need to find. Finally, here, if x cube plus 9x plus 5, again x cube, x square part is missing, it's 0, then 9x plus 5, divide by x. What is it? Divide by x. What is the remainder? The x minus c, x minus 0. Put the 0 directly in place of x, you will directly find, okay? Because the remainder is equal to p of c. Finally, I would like to show one more example, and the answer is very straight. When the polynomial p x cube minus 5x square plus 2x minus 10 is divided by x minus 5, which of the following is not true? I would like to leave this question to you, because you don't need to solve this problem. If you have some basic knowledge, just go through the answers, you will find very easily what is the right answer, isn't it? You can comment the answer here and the method you used also. Smart work works here, okay? You don't need to solve this problem, you need an idea. Thank you.